Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Calculus. Topic Applications of Derivatives. Exercise Miscellaneous. Examples on Chapter 6. Using differentials, find the approximate value of each of the following. Piriba asigi approximate value putu using differential sizinaraga. Let f of x denote the given function x to the power 1 by 4. Then its derivative is 1 by 4 x to the power minus 3 by 4. Let x equal to 16 by 81 and x plus delta x equal to 17 by 81, so that delta x or dx equal to 1 by 81. Now f of x plus delta x equal to f of x plus f dash x into delta x approximately. Sige formula si then whose value is f of 17 by 81 and whose value is f of 16 by 81 plus f dash of 16 by 81 into delta x की value the 1 by 81, and which is equal to, by this rule we get 17 by 81 to the power 1 by 4. This is also 16 by 81 power 1 by 4 plus f dash of x t 1 by 4 later x the 16 by 81 power minus 3 by 4 into 1 by 81 sigi square root t 2 by 3 whole power 4 ni kakatnare asum na sigi su 2 by 3 power 4 ni kakatnare badi 3 pange. We get this, and this is 2 by 3, this is what, this is 1 by 4 into 27 by 8 into 1 by 81, and then this is 2 by 3, this is what, this is 1 by 96, and whose sum up we get this, and 65 by 96. By dividing we get 0.677, which is the required value. For B, let f of x equal to x to the power minus 1 by 5. Its derivative is minus 1 by 5 x power minus 6 by 5 minus 1 by 5 x to the power minus 6 by 5. Let x equal to 32 and x plus delta x equal to 32, so that delta x equal to 1. Now f of x plus delta x equal to f of x plus f dash x into delta x approximately, and f of x plus delta x t 33 ni and x t 32 ni, we get f dash of x t f dash of 32 into delta x ki value 1. This is what by given rule gimatung in a d, which is 33 whole to the power minus 1 by 5, sin 32 whole to the power minus 1 by 5 plus, and this is what CD minus 1 by 5 x the 32 PC law minus 6 by 5 into 1, and whose value is 2 power 5, that which is 2 power 5 calculated 2 power minus 1, that is 0.5, and this is minus 1 by 5, which is 2 power 5 calculated 2 power minus 6, that is 1 by 64 into 1, and sum up we get this, and 1 divided by 320 we get 0.0031, Khaiduk Narabadi 0.4969, and lastly we get approximate locality 0.497. Question number 2. Show that the function given by f of x is log x by x has maximum at x equal to e. Piriba function sigi x ki value e the maximum value laigani utlu. Here f of x is log x by x, and whose derivative by quotient, applying quotient rule we get this. Again its second order derivative is also by applying quotient rule we get this. For maxima or minima we have to put f dash x equal to 0, whose value is 1 minus log x by x square equal to 0. That gives log x equal to 1, and which gives x equal to e. Now f double dash of e, we have to put x equal to e in the f dash x, we get minus 1 by e cube, which is less than 0. Thus f has maximum at x equal to e, hence proof. For question number 3, the two equal sides of an isosceles triangle with fixed base B are decreasing at the rate of 3 cm per second. How fast is the area decreasing when the two equal sides are equal to the base? The two equal sides of an isosceles triangle with fixed base B are decreasing at the rate of 3 cm per second. How fast is the area decreasing when the two equal sides are equal to the base? Let y be the area of the isosceles triangle when x is the length of its equal sides. Then dy by dx is minus 3 centimeter per second, and the area y is half base into altitude. Altitude is applying Pythagoras theorem. Altitude becomes this, and dy by dt we get b by 2 into applying 1 by root over of something whose derivative is 1 by 2 root over of something into something derivative twice x dx dt, and simplifying we get this. When x equal to b, dy by dt becomes a negative number. Thus, the area is decreasing at the rate of root over 3b square centimeter per second when x equal to b. Why it is called decreasing? Because it is minus. Question number 4. Find the equation of the Norman to this curve at a point this. The curve is y square equal to 4x. Therefore, its derivative with respect to x is this. And from this, we have to find out dy by dx, whose value is 2 by y. Slope of the Norman at 1, 2 is minus 1 divided by slope at this point d. Minus 1 divided by 2 by y. That is 2 by 2. We get minus 1. Therefore, the equation of the Norman at 1, 2 is y minus y1, that is 2, equal to slope of the Norman times of x minus x1, that is 1. Solving, we get x plus y minus 3 equal to 0. This is the required equation of the Norman. For question number 5, so that the Norman at any point theta to this curve x equal to this and y equal to this is at a constant distance from the origin. Here x is in terms of theta, y is in terms of theta. Therefore, dx by d theta we get this, and dy by d theta differentiating with respect to theta we get this. Therefore, the equation of the Norman at any point theta is y minus y1. Y minus y1 equal to minus 1 times of slope of the tangent dy by d theta by dx by d theta is this divided by this, that is tan theta, times of x minus x1. X1 is this point. Converting tan theta into sine by cos, we get this. Transferring this is equal, which is the Norman form of a line. Thus, the Norman is at a constant distance a from the origin. Thus, the Norman is at a constant distance a from the origin. Hence, proof. For question number 6, find the intervals in which the function f given by f of x is increasing and decreasing. Function f asi increasing amasung decreasing oiba intervention putu. Here f of x is this, whose first order derivative is by applying quotient rule we get this. Cancelling green, red, and simplifying the remaining we get this. For f of x to be increasing, we have to put f dash x greater than 0. The value of f dash x is this, which must be greater than 0. That is, a cos x must be greater than 0. Therefore, f of x is increasing in first quadrant, that is 0 to pi by 2, and 3 pi by 2 twice pi, that is 4 quadrant. For f cos of x to be 0 or positive. Again, f of x is decreasing if f dash x less than 0, that is whose value less than 0, that is cos x less than 0. Therefore, f of x is decreasing in second quadrant from pi by 2 to 3 pi by 2. Second quadrant, third quadrant. Question number 7. Find the intervals in which the function f given by this is increasing and decreasing. Here f of x is this, whose derivative is this. For f of x to be increasing, f dash x should be greater than 0, whose value is this. This should be greater than 0. Factorizing, we get this, and again this cannot, second factor cannot be 0, which should be positive. Dividing on both sides, we get this. Product of these two factors should be greater than 0, that is x should be less than -1 and x should be greater than 1. Therefore f of x is increasing in intervals -1, -infinity, -1, and 1 and infinity. For Roman number 2, f of x is decreasing if f dash x less than 0, that is x power 6 minus 1 less than 0, that is factorizing, we get this. Product of these two factors less than 0, that is x will be lying between -1 and 1. Therefore f of x is decreasing in -1, 0, union 0, 1, as x cannot be -1, x cannot be 0. For question number 8, find the maximum area of an isosceles triangle inscribed in the ellipse x squared by a squared plus y squared by b squared equal to 1, with its vertex at one end of the measured axis. Let ABC be an isosceles triangle having one vertex at A0, as in this picture. Let B a cos theta, B sin theta, and C equal to a cos theta minus B sin theta. Area of the triangle ABC denoted by A, which is equal to half into base into altitude. And lastly, we got A is expressed in terms of theta. Therefore, dA by d theta, differentiating A with respect to theta, we get AB cos theta and minus AB cos of twice theta, whose second order derivative with respect to theta is also this. For maxima or minima, dA by d theta equal to 0 gives cos theta minus cos twice theta equal to 0. Solving, cos theta equal to cos twice theta gives theta equal to twice pi minus twice theta. That gives theta equal to twice pi by 3. Continue. When theta is twice pi by 3, the value of second order derivative is this, and which is, after simplifying, we get less than 0, a negative number. Therefore, maximum area is AB sine twice pi by 3 minus AB by 2 sine of 4 pi by 3. Solving this, we get 3 root 3 by 4 times of AB square units. This is the maximum area. Question number 9. A tank with rectangular base and rectangular sides open at the top is to be constructed so that its depth is 2 meter and volume is 8 meter cube. If building of tank costs rupees 70 per square meters for the base and rupees 45 per square meter for sides, what is the cost of least expensive tank? A tank with rectangular base, a tank with rectangular base, rectangular sides open at the top is to be constructed so that its depth is 2 meter and volume is 8 meter cube. If building of tank costs rupees 70 per square meters for the base and rupees 45 per square meter for sides, what is the cost of least expensive tank? Let x and y be the length and breadth of the tank. Then the volume of the tank is B equal to 2 times of x, y. Why 2? The depth is 2, it is given, and meter cube. But volume of the tank is given as 8 meter cube. Equating these two quantities, we get twice x, y equal to 8. That gives y equal to 4 by x. Area of the 4 walls is 2 times of x plus y. Which is perimeter into 2, that is 4x plus 4y, and y is replaced by 4 by x, we get 4x plus 16 by x. Area of the base is x, product of xy, that is 4. Therefore, cost of construction is denoted by C, which is equal to rupees 70 into 4 plus 45 into area of the 4 walls, which we get this, which is in terms of x. Now dc by dx, differentiating this with respect to x, we get this, and its second order derivative is also this. Question number 9. For minima or maxima, dc by dx should be 0. This gives this value. From this we have x is 2. X cannot be minus 2. When x is 2, second order derivative, its value is positive. Thus c is minimum when x equal to 2 and y equal to 4 by 2, that is 2. Hence the cost of construction of the cube x replaced by 2, we get rupees 1000. Hence find out. Question number 10. The sum of the perimeter of a circle and square is k. The sum of the perimeter of a circle and square is k, where k is some constant. Prove that the sum of their areas is least when the side of the square is double the radius of the circle. Let r and x be the radius and length of one side of the square. Then twice pi r, this is the perimeter of the circle. For x, which is the perimeter of the square, their sum is given as k, which is equal to k. Let ax be the sum of their areas. Then ax is pi r square plus x square. Now r is replaced. Solving r from the above equation, we get this, and simplifying we get this, and differentiating a with respect to x, we get this, and its double derivative with respect to x is 8 pi plus 2. For maxima or minima, a dash x should be 0, and this gives, from this we have to solve x, that is k by 4 plus pi. When x is equal to k by 4 plus pi, a double dash of x should be greater than 0. Thus a of x is least when x is k by 4 plus pi, and r is k minus 4x by twice pi. X is replaced by its equivalent value, and solving we get x by 2. That is x equal to twice r. Hence the sum of areas is least when the side of the square is double the radius of the circle. Hence proof. For question number 11, a window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is 10 meter. Find the dimensions of the window to admit maximum light through the whole opening. A window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is 10 meter. Find the dimensions of the window to admit maximum light through the whole opening. Let A, B, C, D be a rectangle and a semicircle is drawn with CD as per diameter. Let A be equal to x meter and BC equal to y meter. Therefore, perimeter of the window is x plus twice y plus pi x by 2 equal to 10, which is given as 10. Then solving y from this equation, we get y equal to this. Let ax be the area of the window. Then area of the window is area formed by rectangle plus half of the circle. Half of the circle, we get this, which is in terms of x and y. Y is replaced by x. We get this. Therefore, a dash of x is this, and its second order derivative is also this, which is equal to minus 4 plus pi plus 4 by 4. Question number 11 continued. For maxima or minima, a dash x equal to 0 gives this, and solving x equal to 20 by pi plus 4. When x is this, a double dash of x should be less than 0. Therefore, a of x is maximum when x is 20 by pi plus 4 meter, and y is x की respective value in terms of y the phong y in terms of x the phong or x to 20 by pi plus 4 पिछले law we get 10 by pi plus 4 meter phangé. The dimensions of the rectangle are 20 by pi plus 4 meter by 10 by pi plus 4 meter. Question number 12. A point on the hypotenuse of a triangle is at a distance A and B from the sides of the triangle so that the minimum length of the hypotenuse is A to the power 2 by 3 plus B to the power 2 by 3 whole power 3 by 2. Let A or B be a right angle triangle. Let C be a point on AB such that its distance from OA equal to small a and OB equal to small b. That is CD. CD is equal to A and CE is equal to B. Let angle OAB equal to theta, which is equal to angle ECB which is also theta. Then AC is equal to A cosec theta, BC is equal to B sec theta. Let I theta be the length of the hypotenuse AB. Then I theta equal to AC plus BC. AC is already equal to A cosec theta and BC is equal to B sec theta. Taking derivative with respect to theta equal to, we get this, and its second order is also, we get this. For maxima or minima, is dash theta equal to 0 gives this expression equal to 0. Then solving tan theta equal to A by B whole to the power 1 by 3. That is theta equal to tan inverse of A by B to the power 1 by 3. When theta is this, maximum value of is theta is A cosec theta plus B sec theta. Cosec theta into converted into tan theta and sec theta into tan theta, and putting their respective values, we get this. Solving this. Question number 13. Find the points at which the function f given by this has locale maxima, locale minima, point of inflection. Function asigi karamba points in the locale maxima laigani, locale minima laigani, point of inflection laigani. Let us solve. Here f of x is this, whose derivative is applying product rule, we get this, and the factorization gives this. For maxima or minima, f dash x equal to 0, solving this equation equal to 0, we get this equal to 0, or x minus 2 equal to 0, or x plus 1 equal to 0. Solving x, we have three values of x, that is 2 by 7, 2 minus 1. When x is less than minus 1, f dash x is minus product plus their product is positive. When x is greater than minus 1, f dash x is minus plus their product is positive. Therefore, f dash x does not change the sign. F dash x does not change the sign. Thus, x equal to minus 1 is a point of inflection. When x is less than 2 by 7, f dash x its value is positive. When x is greater than 2 by 7, f dash x is minus. We have changed from plus to minus. Therefore, f dash x changes sign from plus to minus. Thus, x equal to 2 by 7 is a point of locale maxima. Positive to minus the sense or x value hengalakpa matamda adu rabadi aduguma point adu the point of locale maxima ore. Again, x is less than 2, f dash x its value is minus. When x is greater than 2, f dash x is positive. Therefore, f dash x changes sign from minus to positive, minus to positive. Thus, x equal to 2 is a point of locale minima. Question number 14. Find the absolute maximum and a minimum values of the function f given by this in the closed interval 0 pi. Here f of x is this, its derivative is this. For maxima or minima, put f dash x equal to 0, we get this. Solving cos x times of this, cos x is equal to 0, sin x is half. Solving x equal to pi by 2 or x equal to pi by 6 or pi by 6. When x equal to this or this. Now f of 0 gives, f of 0 is from given interval, we get 1. F of pi by 6, that is 30, we get pi by 4. F of pi by 6 is also pi by 4, and the f of pi by 2 is 1, f of pi is 1. Therefore absolute maximum value is maximum value of the above given 1, pi by 4, pi by 4, 1, 1. Maximum of out of them is pi by 4, and the absolute minimum value is 1. Question number 15. So that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is. So that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is 4r by 3. Let ABCD be the cone inscribed in a sphere of radius r and center O. Let B be the volume of the cone and the O be equal to x. Then volume is 1 by 3 pi r square into is, which is this. Now dB by dx is this, and its second order derivative is also this. For maxima or minima, we have to put dB by dx equal to 0. That is, this equal to 0. Factorization gives x equal to r by 3 or x equal to minus r. Therefore x equal to r by 3 is taken, since x equal to minus r is invalid. When x is equal to r by 3, second order derivative becomes a negative. Thus B is maximum when x equal to r by 3, that is volume of the cone is maximum when altitude is dO plus OB, that is r plus r by 3, that is 4r by 3. Hence proof. Question number 16. Let f be a function defined on closed interval AB such that f dash x greater than 0 for all x belongs to closed interval AB. Then prove that f is an increasing function on open interval AB. This is open interval AB. Let x1, x2 belongs to closed interval AB such that x1 is less than x2. Then f of x is continuous on closed interval x1, x2, and differentially on x1, x2 closed interval. So by mean value theorem, there exists a real number c belongs to open interval x1, x2 such that f dash of c is equal to f of x2 minus f of x1 by x2 minus x1. Since f dash x should be greater than 0 for all x belongs to open interval AB, f dash x should be greater than 0, and whose value is equal to this, which should be greater than 0, that is this transfer the denominator in this side, we get this, which shows that f of x2 is greater than f of x1. Thus x1 less than x2 implies f of x1 less than f of x2 for all x1, x2 belongs to open interval AB. Therefore f is an increasing function on open interval AB. Question number 17. So that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius capital R is twice r by root 3. Also find the maximum volume. Radius capital R oibe sphere amagi manungda yawba ngamba maximum volume piba ngamba cylinder adugi height to twice r by root 3 oigani. Maximum volume adusu putu. Let B be the volume, R the radius of base, and is be the height of the cylinder. Then B equal to pi r square is, and r is equal to small r square is equal to this, and which is this. Therefore now B is function of small is, therefore dB by d is pi by r square minus 3 is square by 4, and its second order derivative is also minus 3 pi is by 2. For maxima or minima, we have to put dB by d is equal to 0, that is this equal to 0 gives is equal to twice r by root 3. When small is twice r by root 3, then second order derivative is also a negative number. Therefore, I is equal to twice r by root 3 is a point of maxima. Thus, the maximum volume of the cylinder is I is replaced by its equivalent value. After solving, we get 4 pi r cubed by 3 root 3. Hence, find out. Question number 18. Show that the height of the cylinder of greatest volume, which can be inscribed in a right circular scroll of height s and semi-vertical angle alpha, is one-third of the one-third depth of the cone, and the greatest volume of the cylinder is 4 by 27 pi s cubed into 10 square alpha. Show that the height of the cylinder of greatest volume, which can be inscribed in a right circular cone of height s and semi-vertical angle alpha, is one-third depth of the cone, and the greatest volume of the cylinder is this. Let us prove. Let x is b be the radius of the inscribed cylinder, height of the cone, and volume of the cylinder. Then b equal to pi x square is minus a is equal to x cot alpha. Then b equal to, solving this, now b is function of x only. Therefore, dv by dx is twice pi is x and 3 pi x square cot alpha. And its a second order derivative with respect to x is also this, as in this picture. For maxima or minima, we have to put dv by dx equal to 0. That is, this equal to 0. Gives x equal to 2 by 3 times of is 10 alpha. When x is this value, its second order derivative, we get less than 0, a negative number. Thus, the volume of the cylinder is maximum when x is this. That is, the height of the cylinder is equal to is minus 2 by 3 is 10 alpha into cot alpha, that is is by 3. Also, maximum volume is equal to 4 by 27 pi is cubed 10 square alpha. Hence, proof. For question number 19, a cylindrical tank of radius 10 meter is being filled with at the rate of 314 cubic meter per hour. Then the depth of the width is increasing at the rate of cylindrical tank of radius 10 meter is being filled with at the rate of this. Let is be the depth of the cylinder. Then its volume is pi r square is, that is, r is 10. We get 100 pi is. Now dv by dt is 100 pi d is by dt, and dv by dt is given as 314. From this we have d is by dt is 1 meter per hour. Correct answer is option A. Question number 20. The slope of the tangent to this curve at the point this is. The slope of the tangent is given by dy by dx, which is in this case given by dy by dt by dx by dt. Their derivatives are this. When x equal to 2 and y equal to minus 1, we get t square plus 2 thrice t minus r equal to 2, and this equal to 1 minus 1. And the factorization gives t equal to minus 5 to t equal to 2 minus 1. That is t equal to 2. Therefore, slope of the tangent is the two official law. We get 6 by 7. Correct answer is option B. Question number 21. The line y equal to mx plus 1 is a tangent to this curve if the value of m is y square equal to 4x. Differentiating both sides with respect to x, we get dy by dx is 2 by y. We have m is equal to 2 by y. Let px1 y1 be the point on the curve at which the tangent is parallel to the line. Then the point will satisfy the equation of the curve, that is y1 square equal to 4x1, and m is equal to 2 by y1. The equation of tangent at this point is y minus y1. Slope of the tangent is 2 by y1 times of x minus x1. Solving y, we get this. Comparing this equation with y equal to mx plus 1, we get y1. y1 minus twice x1 by y1 is equal to 1, and y1 square, we get this y1 becomes 0 or 2. When y1 is 0, m is infinity. When y1 is 2, m is 1. Your correct answer is option A. Question number 22. The normand at the point 1, 1 on the curve, this is. Here the curve is this, differentiating both sides with respect to x, we get dy by dx equal to minus x. Normand at this point is y minus y1 times slope of the normand is minus 1 divided by slope of the tangent is minus 1. The x minus 1, we get y equal to x. Y equal to x. Correct option is B. B and D are equal, but correct option is B. For question, the normand to this curve passing through this is also, the equation of the normand at this point is y minus y1 times slope minus 1 divided by slope of tangent at this point is x1 by 2 x times of x minus x1. Solving this, since it passes 1, 2, so x the 1 पिछलो y the 2 पिछलो, we get a relation between x and x1 and y1. Solving this, y1 is 2 by x1. Also x1 y1 lies on this curve. The point or the coordinates of this point will satisfy this curve, we get this. And now x1 square, y1 square is x1 square by 4. But y1 is already found to be 2 by x1. 2 by x1. And solving, x1 is 2. Also y1 is 2 by 2, that is 1. Thus the normand passing 1, 2 is the normand at 2, 1. That is y minus 1 by minus 2 by 2 times of x minus 2, that is minus x plus 2. Solving, x plus y equal to 3. Correct option is answer A. Question number 24. The points on the curve where the normand to the curve makes equal intercepts with the axis are. The points on this curve where the normand to the curve makes equal intercepts with the axis are. Here y, the curve is 9 times of y square equal to x cube. Differentiating both sides with respect to x, and we get dy by dx is x square by 6y. Let x1, y1 be the point on the curve. Since this lie on the curve, the coordinates will satisfy the equation of the curve, which is equation 1. Since normand makes equal intercepts with the axis, so slope of the normand will be plus minus 1. So then oirani implies slope of the mathakta lahore, which she the sinjalo, equation sinjalaba matuk the plus minus 1 singa manahale y1 equal, we get equation 2. From equation 1 and equation 2 solving, eliminating y1, we get this, x1 is 4, y1 is in equation 1, or in equation 2 y1 is this. Therefore the required point is 4 plus minus I by 3. Correct option is A. Thank you for watching my video.